Hey everyone, I'm Rohit Singh. I'm a data and AI content creator, and I'm really excited to be sharing my very first explainer with you all. Today, we're going to dive into a pretty radical idea that might just change how we think about teaching AI to understand documents. We're talking about a leap from just matching words to something, well, a lot more like actual logical reasoning. So let me just kick things off with a big question. What if the way we've all been doing this, retrieval-augmented generation, or RAG, has a fundamental flaw? What if in our effort to make things simple for the machine, we've actually been making it harder for it to genuinely understand? So to get to the bottom of that, let's first do a quick recap of the standard method, the one we're probably all familiar with, traditional vector RAG. The standard pipeline, right? It goes a little something like this. We take a document, and then we use this brute force method called chunking to just slice it up into smaller, often totally random pieces. After that, we turn those text chunks into numbers, we call them embeddings, and we dump them all into a vector database. Then, when a user asks a question, we just search for the chunks that are mathematically the most similar. And that right there is the key. The entire system is built on finding the closest vector. But here's the thing. Closest doesn't always mean it's the right answer, does it? This method often completely misses the logical flow of a document. It might grab paragraphs that share a keyword but have absolutely nothing to do with each other in context. Okay, so now let's look at a completely different way of thinking about this, what's being called vectorless tree RAG. Instead of basically shredding the document, this approach tries to mimic how you or I would actually read it. The whole philosophy here is to reason like an expert. I mean, think about it. If I handed you a 500-page technical manual and asked you a specific question, you wouldn't start reading on page 1 word for word. No way. You'd look at the table of contents first, get the lay of the land, and then jump straight to the relevant chapter. Well, this method teaches the AI to do exactly that. And the engine behind this whole thing is something called an LLM Tree Builder. This is where a large language model does a first pass on the document, not to chop it up, but to understand its structure. It's looking for chapters, for sections, for subsections, and it builds this incredible structured map of the entire document. So really, when you boil it all down, the core difference between these two methods happens right at the very beginning. It all comes down to one thing: how they index the information. On one side, you've got traditional chunking. Let's be honest, it's a blunt instrument. It's like taking a finely crafted argument and just slicing it into pieces, sometimes splitting a coherent thought right down the middle. But on the other hand, you have this hierarchical tree that actually respects the document structure. It's the difference between having a pile of bricks and having the actual blueprint for the house. Now, what's so cool is that at the end of this new indexing process, you don't end up with a massive, complex vector database. You got a single human-readable JSON file. This thing is basically a treasure map of the document, where each point on the map represents a section and even holds a little summary of what's inside. Okay, so that's indexing. But what about actually finding the answer? This fundamental difference in how we index totally changes the retrieval game. This is where that reasoning part really starts to shine. You see, traditional RAG is all about a mathematical search for similarity. It's asking which one of these random chunks sounds the most like the question. But tree RAG, it performs a logical traversal. It asks a much smarter question. Given the structure of this document, where is the answer most likely to be? The whole process is just, well, it's elegant. The LLM gets the user's query and that JSON tree, that map we talked about. It scans the map, figures out which chapters or sections are relevant, and then it goes directly to them. It then uses those pre-summarized bits of content to build a really precise answer. And it can even cite the exact section it came from. All right, but I can hear you asking the question already. This sounds great for a well-structured document, but what about the messy stuff? What happens when you have a PDF with no structure at all? Let's tackle that head on. What if the document has no table of contents? Is there no map for the AI to follow? Does the whole system just fall apart? And this, for me, is the most brilliant part of this whole approach. If the LLM sees there's no table of contents, it just makes one. Seriously, it reads the document, it figures out the headings and the structure all on its own, and then it does something called section-aware splitting. It respects the logical boundaries it just discovered, and then it builds that JSON tree from scratch. That is a massive leap beyond just blindly chunking text. So where does this leave us? What does this shift from a statistical search to logical navigation actually mean for the future of how we build these AI systems? Because this is more than just a new technique. It feels like a whole new way of thinking. let's just break it down one last time. Traditional RAG, it's all about brute force chunking, vector databases, and similarity search. And its whole goal is to find what's similar. Tree RAG, on the other hand, uses a section-aware hierarchy, a single JSON index, and LLM-driven traversal to find what is logically relevant. We're moving from just pattern matching to something that feels a lot more like real comprehension.
And that brings us to one last, pretty provocative thought. For years, right, vector databases have been the absolute cornerstone of RAG architecture. But if an AI can now read, understand, and navigate a document's own structure all by itself, do we still need them for this? Are these complex databases on their way of becoming obsolete for this kind of work? Now that is a question that could really redefine the entire field.